example 1C of further simultaneous equations. I want to welcome you to this lesson. Now, so far we've been looking at the various methods of simultaneous linear equation and how to use them to solve further simultaneous equations. Now, on the board, we are having the first equation as 1 upon x minus, then we have 5 upon y equals to 7 as equation 1. Then we're also having 2 upon x plus 1 upon y equals to 3 as equation 2. Now let us progress. The method I want to use here is, I want to use the Gaussian elimination method, okay? So that's the method I shall be using to solve this problem. But first, we need to resolve what we have here. I am going to write this in their inverse form. That is, I'm going to write them in their index form rather. So in equation 1, my 1 upon x can be written as x power minus 1, then write out our minus. Then our 5 upon y can be written as 5y power minus 1, then everything equals to 7. We are going to do the same thing here to equation 2. So 2 upon x is still the same thing as 2x to power minus 1, then plus 1 upon y is the same thing as y to power minus 1, then everything equals to 3. So this is the first thing we are going to do. Then the next thing we are going to do now, since we are using the Gaussian elimination method, we are going to write out very quickly the augmented matrix. First of all, rather the coefficients of our x to power minus 1 in both equations. So we have 1 and 2, then we have minus 5 and 1. Then we rule our line. I'll put our result value, which is 7 and 3. Then we close the brackets. At this point, please, if you are just joining us and you are wondering what we are doing, well, we are using the Gaussian elimination method to solve these two simultaneous equations. And if you want to really be vast at using this method, then I would like to refer you to our previous videos. Please go and watch them after this lesson, and your knowledge base will be expanded. Now let's get back to what we are doing. At this point, we have 1 and minus 5 and 7 as the elements on the first row. So write it as row 1. Then 2, 1 and 3 as elements in the second row. So write it as R2. Alright, so what do we do with this? Now don't forget, we are using the idea of elimination method. So which means in eliminating these two values here, the coefficient for x power minus 1, we must make sure that the two coefficients must be the same. So we are going to use 2 to multiply everything in row 1. So we say 2 multiplied by row 1. And we use 1 to multiply everything in row 2. But bear in mind that the two signs are the same. We are having a positive sign here. So that means that since the signs are same, we are going to subtract. And then 1 times everything in row 2 will give us row 2. The idea is that we are going to change everything in row 2 to become the second row will have a different element. Okay, so let's write this out like as I've taught you in the previous lessons. Let's write everything out here. Let's translate all these things we wrote out here. Okay, 2 times all the elements in row 1 means we are going to use 2 to multiply everything here. 2 times 1 will give us 2. Then 2 times minus 5 will give us minus 10. Then 2 times 7 will give us 14. Then 1 times all the elements in row 2 here will give us 1 times 2 will give us 2. 1 times 1 is 1, and 1 times 3 is 3. We can close the bracket. Now the results, we are going to translate the results down here. Don't forget, everything in the first row will be written out as 1 minus 5, and then we'll write out our 7. Then we simplify this to get the second row for this particular matrix. So 2 minus 2, where do we get the minus from? Don't forget, that's what we wrote out here. So 2 minus 2 is 0. So we have now achieved a 0 under what we have here, okay, under this first element. Now minus 10 minus 1 will give us minus 11. Then 14 minus 3, that will give us 11. Now what does this mean? You can see that since we have obtained a 0 here, okay, in the first element in this second row, it means that the value for x power minus 1 has been eliminated. Then our minus 11 here tells us that our y power minus 1, our y power minus 1 has the coefficient of what? Minus 11. So we are going to translate this value and send it up. Now we'll go this way, okay, and we take it out from here. So we write our minus 11y power minus 1 will give us the result value here is what? 11. So which means if we divide both sides by minus 11, this will cancel out this. We have y to power minus 1 to equals to what? Minus 1. So if we reverse this, that is 1 upon y, that means we're having minus 1 upon 1. And therefore, we can take the value of y. If we reverse this, okay, the y comes up, the 1 comes down, this one comes up, the minus 1 comes down, it means that we are still going to have minus 1 as the answer to question for the value of y. So y is equals to what? Minus 1. Now, why do we need all these values? We need it so that we can be able to get the values for our x. So what does that mean? We take this value, either we use this y equals to minus 1, but I would prefer we use 1 upon y, which is z, which is y power minus 1 equals to minus 1. Okay, we are going to use it to replace the value for y in this value here. So we have 2x power minus 1, then minus 10y power minus 1 equals to what? 14. Now what does this mean? It means 2x power minus 1, then minus 10 into bracket. Now y to power minus 1, consider y to power minus 1 is equals to minus 1. So put the minus 1 here, then equals to 14. This will give us 2x to power minus 1, then minus minus is plus, 10 times 1 is 10, we have equals to 14. Send this one to the other side, we are going to have 2x to power minus 1 equals to 14 minus 10. This gives us 2x to power minus 1 equals to 4, because 14 minus 10 will give us 4. Now if we divide both sides by 2, this will cancel out to give us x to power minus 1 equals to, this will give us 2. Okay, so our x to power minus 1 is still the same thing as x to power x upon what? 1 upon x. Then if we are writing this one out as 1 upon x, then that means that we are having this as 2 upon 1. Please take note of what we are doing here. This x to power minus 1 is actually the inverse of x, which means 1 upon x. So now this 2 will remain where it is, and we can write it as fraction, which is 2 upon 1. So if we take this x up, it will become x upon 1. Then if we take this one up and the 2 comes down, it will become half. So that is going to give us the value for x. So the solution to this problem on the board is that y equals to minus 1 and x equals to what? Half. I believe you follow me through this lesson and you also have learned something new. Please, if you enjoyed this lesson, I would like you to give me a thumb up, give this lesson a thumb up, all right, and leave a comment in the comment box. Subscribe if you have not done so. Click the bell icon so that you'll be notified when the next video is coming up. We are going to see how to apply the various methods of simultaneous equation to solving other problems. Please stay tuned and I will see you in my next lesson. Thank you very much for your time.